Ladies and gentlemen, it is that time. We're going to play this just like we're actually doing the quiz. So, we're going to fill in the unit circle first. At this point, this is, I believe, time number 4 we've done this, so we're going to roll. Degree measures, I'm doing my multiples of 30 first. And if some of you are going, dude, slow down, you're going too fast. No, you know what this is called? This is called being prepared and having practiced. Because, as I've mentioned before, you have got a class period, plus passing if you need it, to be able to get this stuff done. This and the actual quiz that goes with it. So you're going to need to have a grip, 45, 45, 45, 45, of your multiples to be able to whip around. You're not going to have the time or a calculator to be able to be doing this anyway. Okay? When we get to our radian measures, reminder, we just got to get that first one started. 30 divided by 180. Think about the zeros are gone. 3 over 18 is 1/6. And we follow the pattern. 1 pi over 6. 2 pi over 6. And if you want to actually put all the over 6's in and reduce, you can. But you have to get them reduced. 3 pi over 6. 4 pi over 6. 5 pi over 6. Here comes our first checkpoint. 6 pi over 6. Or pi, because we know the pi is 180. 7 pi over 6. 8 pi over 6, reduced. 9 pi over 6, reduced. 10 pi over 6, reduced. 11 pi over 6, reduced. 12 pi over 6, 2 pi. Boom. And then my 45. Even if I have to take a minute to think about it, and reduce it by hand, 45 over 180 reduces to 1 over 4, or pi over 4. 2 pi over 4. 3 pi over 4. Here comes my checkpoint. 4 pi over 4. 5 pi over 4. 6 pi over 4 reduced. 7 pi over 4. And my last checkpoint, 8 pi over 4. Okay, rolling. We're like 2.5 minutes in, just zipping. When it comes to my measures, reminders, it's cosine and then sine, just like in the alphabet. Everything's divided by 2. We've talked about that before. And we've also talked about how cosine goes from biggest number down to smallest. So square root of 3, square root of 2, 1. 3, 2, 1, largest to smallest. Sine, just the opposite. 1, square root of 2, square root of 3. 3, 2, 1, 1, 2, 3. Cool thing about that, you now have all of the values to work with all the way around. If I deal with my reference angles. Here's my 30-degree reference. Again, reference angle. 30 degrees away from the x-axis. So I'm looking in each quadrant for the degree measure that's 30 degrees away from the x-axis. So for all of those, I use the same values for cosine and sine. Now I'm not quite done with these when I work my way around because I still have to think about the signs that go with them. Now at this point you can do the signs on these. Probably a good idea so you don't forget. Or you could do all your angle measures and then go back. Okay, both of them are legit ways of doing it. So if I'm going to do signs first, again, first quadrant's all, so I didn't have to think about it. All students, which is sine. Remember, sine is your second one, which means that'll be positive. So your first value will be negative on all of these. When I get to the third quadrant, that's the tangent quadrant, which means neither sine or cosine will be positive. So maybe we just put all our signs in before we even start. All students take calculus, cosine. Oh, that's not. Cosine's positive, Harty. Positive. So my second one will be negative on all of those. So once now I've gone through, got my signs situated, I can go back through and finish off my reference angles. So all my 45-degree reference angles are going to have square root of 2 over 2. And now that I put all my signs in ahead of time, I can just kind of whip my way around and have those all in. And then the one that's left, I could use another color, but there's only one without color, so I think it's kind of obvious at this point that that's going to be my 1/2 square root of 3 over 2. And I work my way around with that. And then my last thing, I've got my quadrantals, my angles that are on the axes. So, remember, this is a unit circle. Here's my origin. I'm going 1 to the right, which is my x value. I'm going 1 up, which is my y value. I'm going 1 left, which is an x value. And finally, I'm going 1 down, which is a y. Approximately 6.5 minutes, I'm good to go. Okay, and remember, I get to use this on the quiz. That's even better. It's going to make my life easier when I get a little bit further. But for now, that out of the way, time to move to the quiz. Okay. So, for each of the following, name the center line, the amplitude, the period, the phase shift. Okay, as long as you label, I'm not worried about this part, labeling the ordered pairs. As long as you label your axes, label your values. Some of you may choose to draw your little charts up at the top, maybe something like this, just to remind you as you get going, here's my base angle measures, here's my sine, and then maybe do it with cosine as well. Or some of you may just do it as you go, like I'm going to do on here. So, go ahead, get this drawn in. We got cosine here at the start. And what I like to do is I like to label these. So let's see here. What do I know? My amplitude is my A. That's -4. My period is my B, but there is no number right in front of cosine besides my amplitude. Okay, like there is down in number 3, let's say, where there's a 3. So my B value is 1, which means my period is still just 2 pi, because we do 2 pi divided by B. My phase shift normally would be my C value. That's what's in parentheses, but I don't have any of that here. So that's none, or I guess you could say 0. And then my center line, my vertical shift, would be if there was a plus or minus at the end or beginning, sort of like there is here, but there isn't one. So even though there's none, my center line then is at 0, because I didn't move up or down at all. So as I take a peek at what this is going to look like, and again, you're at a point that if you have practiced these should be whipping off as fast as I'm doing them. This shouldn't be, But again, remember, if you have a brain cramp, those quadrantal angles that we did before can get you all the sine and cosine values that you need. Just saying. Okay, so when we get here, my theta always has to do with, do I have a period change? No. Do I have a phase shift? No. So my angle measures aren't going to change here. Okay, because these are the two that go with theta. These are the two that go with my sine or cosine function. So I have an amplitude value of -4. So we're going to multiply by -4. But I don't have any up or down shifts. So all I got to do is multiply each of these guys by -4. That gives me my trig functions. So I'm ready to go. And as I was saying earlier, as long as you label your axes, I'm going to be able to see where your points are at. And I'm assuming a lot of you are going to have a chart somewhere, so it'd be easier for me to see as well. So 0, -4, pi over 2, 0, pi 4, 3 pi over 2. And again, curvy people, curvy. And I'm set. One function. And again, your center line. Okay, this y equals number. Y equals 0 just means it's going to be on the axis. And I should draw that in. That's going to help us when we get to Friday and we're dealing with finding amplitude and finding the equation once we're given the graph. We need to start getting used to that a little bit. So number 2, we'll try to keep number 1 kind of handy so we can see some things here. We talked about moving that before. So again, I look, is there a number right in front of sign now? Nope, amplitude's 1. Do I have a vertical shift? Not a vertical shirt, no, vertical shift. I do. Up 1 or plus 1 is what we're going to do there. My period, don't have a value in front of the x, so that's still just 2 pi. And my phase shift, which goes on in here, is the opposite of what I see here. So we're going to be going right pi over 4, which mathematically means we're going to be adding pi over 4. Again, I like labeling these just because then when I get over here and I'm kind of thinking this through, I can look and I'm like, okay, here's my 2. Period didn't change. Phase shift this time. Plus pi over 4. So I'm going to add pi over 4 to these. Now before you go into a panic, I don't like my fraction. Again, just think about them as fractions without the pi there. 1/2 plus 1/4 is 3/4. 1 plus 1/4 is 5/4. Worst case scenario, take your calculator and type in 1 plus 1/4. Math, enter, enter. Okay? Because you'll have calculator access at this point. Okay? 3/2 plus 1/4 is 7/4. And 2 plus 1/4 is 2 1/4, or 9/4. And we're set there. I move over to the sign side. I'm like, all right, 0, 1, 0, -1, 0. What's going on this time? My amplitude comes first, because A comes before D. So I'm going to do times 1, but that really doesn't change anything. It's going to be the same thing. Don't worry about it. But then I have to do plus 1. That's the one I'm going to have to make a change with. So I add 1 to each of those values and get myself set with that. So, label my axes. And so now, pi over 4 is 1, 3 pi over 4 is 2, 5 pi over 4 is 1, 7 pi over 4 is 0, 9 pi over 4 is 1. And just like in the first one, wherever that shift was, that's going to be my center line. So before it was at 0, this time I went up 1, so it's at 1. And I'm going to put that dotted line in there and have myself set. Again, this is going to come down to the fact, did you practice with these enough to have a grip on things? If not, we're going to see. And if so, we're going to do all right. I get to 3. And I go, all right. Amplitude, nothing really different. Vertical shift, none. So my y is 0. Period, ooh, period changes this time. My b value is 3. So my period's going to be 2 pi over 3. Okay, that one changed. Vertical shift, no. Why did I do that twice? Silly man. Phase shift, no plus or minus in here. So there's none there. So I start looking at this for a minute. I'm like, dang, I might not even need the chart really on this one. Well, I mean, I'll do a quick one here, but I notice right away, no vertical shift, no amplitude change. Angle measures aren't changing. So, I mean, they're just the same. I really don't even know why I just did that. That was kind of silly. And then cosine, okay, I look and I'm like, okay, what else is going to be going on here? Oh, now, at this point, some of you may have just said, Harty, you're a bonehead. If you're in class, you're probably saying it. At home, you might be doing the same thing. You're like, Harty, these change this value. This is the part that's not going to change, and you're right. See, I'm willing to admit when I do something silly. It happens. Because here, I don't have a phase shift, but my period, I'm dividing all my angle measures by 3, which is the same as multiplying them by 1/3. And when you multiply by 1/3, it just means you're multiplying the denominator number by 3. So in this case, 2 times 3 is pi over 6. And this would be pi over 3. 3 times 2 is 6. So 3 divided by 6 is 1/2. 2 pi divided by 3 is 2 pi over 3. Period matches my period. And now I'm ready to graph. So 0, 1. Pi over 6. Harty. Another reason for showing that you shouldn't do math in pen, as your teacher is attempting to do here. Bad example. But we're going to survive it because we are not a perfect people. Nope. And since we didn't have an up or a down shift, get that sucker in there. So yeah, usually not a good idea to start drawing this information until you've situated your values. Lesson learned. And finally, the big kahuna, you knew it was coming, where I'm going to ask you for everything in one of these. Is there a vertical shift? Oh yeah. Up 1. Center line is at y equals 1. Amplitude, number in front, 3. Period change, you know it. We're going to be dividing by the b value of pi. Let's just cancel those suckers out. And my phase shift, the opposite of what we see, will be left 2 or minus 2. Oh boy. Okay. So let's see. We're going to have a lot to play with this time. So first things first, I'm going to learn from my last boo-boo to get all of my information down first before I start making assumptions. Now I'm also going to remember here that my period and phase shift are what I'm dealing with first. Okay, that again would be my theta. So I'm dividing by pi, which means I'm going to multiply by its reciprocal. And then I'm going to phase shift after that. So I'd probably do this with two separate things rolling here. So multiply by 1 over pi just means the pi's are going to disappear. So pi over 2 becomes 1/2 because the pi's cancel. Pi divided by pi is 1. 3/2, 2, just like my period should be. Once I've done that, now I'm going to take those values that are now just numeric, but minus 2 from each of them. Now, people, we really don't want to do decimals here, okay? Am I going to jump up and down and scream if you go that route? No. Especially when, for the love, my brain goes crazy. That is a negative 3 over 2, because 1/2 minus 2 is negative 1 1/2, or negative 3/2. 1 minus 2 is negative 1. 1 1/2 minus 2 is negative 1/2. 2 minus 2 is 0. Okay? Those are going to be the measures that I'm using. When I move over to sine, now I'm using these. Okay, so my amplitude comes first, then any vertical shift. So I'm going to multiply by 3 and then add 1. 0 times 3 is 0, plus 1 is 1. So all of my zeros will be 1s. 1 times 3 is 3, plus 1 is 4. Negative 1 times 3 is negative 3, plus 1 is negative 2. So you're like, okay, so we're going to put, no, these are negative. We are going to squish these over in the negative half of the axis because we got to show that we know what we're doing. As I pause. All right, so we'll get these labeled. And here we're kind of all over the place, so I'm actually going to count by 2s. We'll see if that causes any grief here in a minute. So negative 2, 1, which would be in between the 0 and the 2 here, of course. Negative 3/2, 4. Negative 1, 1. Negative 1/2, negative 2. And 0, 1. And my center line is at 1. Okay, you survived the mega load question. Good job. Again, if you haven't practiced these as much, grab an extra preview. Actually do some of the homework problems if you haven't. It'll get you some good practice. Okay, just kind of putting it out there. Same number of these tomorrow coming on the actual quiz. So now we get to what hopefully is going to be the easy stuff. Reference angles. Let me zoom in a little bit more here now that we're to the back. So reference angles, reminders. We can look at these in degree measures. Nearest x-axis, that's why I'm using those values. But we also can look at them in radian values. Yeah, the whole begin in radian, end in radian. So when we're in degrees, we'll do those first. Find the closest degree measure to the one you're working with, and just subtract them. 360 minus 300 is 60. Okay. If there's a negative, okay, when you're doing reference angles, ignore it, because reference angles are always positive. Which of these values is closest to 120? 180 is. 180 minus 120. Is 60. Okay? So, degree measures, not so bad. Radians, still not so bad. Because let's use a little common sense here. Forget about the pi for a second. 2/3 is close to 1. Okay? What is 1 minus 2/3? 1/3. Or pi over 3. If I was desperate and I like brain locked with that, punch in 1 minus 2/3 in your calculator and hit math, enter, enter. I do not want to see a decimal. Do not give me 0.33 pi. I will lose my mind. Now somebody's going to do it just to see if I lose my mind. Same here. 5/4, 1 1/4. Closest to 1. Okay? So here I'd kind of think about it as 5/4 minus 1, which is 1/4 or 1 pi over 4. Again, get rid of the pi. Think a little math, enter if you need to, but the negative isn't going to mess with me. Don't let it mess with you. Positive angles always between 0 and 90 degrees, or 0 and pi over 2. Convert degree to radians, radians into degrees. We want radians. Pi is on top. At this point, you have a calculator. A little 135 over 180 math, enter will do you good, even though 45 goes into both of them. Get my answer. If we're in radians and we want to go to degrees, we want to cancel those guys. 7 times 180 is 1260 divided by 4 is 315. And then we get to the exact value. Oh, some of you in the exact value. This should be one of the easier parts, but for some of you, you're going to drive yourself nuts with these. Okay, find the exact value. In other words, use your unit circle. Okay? You're like, well, how do I do that? Okay, let's think about it. Sine of negative 135. All right, let's pull this back up. I'm zooming back out because we're just going to need to be able to see. Remember, we're going clockwise. 90, 120, 135. Okay? Here's where I'm at. So this would be same thing as looking up the sine of 225 degrees, which if I have this, cosine sine, is negative square root of 2 over 2. Keep your life simple, people. Okay? Don't make this hard. 12. Secant of negative 300. What's secant? Secant's the inverse of cosine. So, negative 300, negative 90, negative 180, negative 80, negative 180, negative 270, negative 300, so the 60-degree angle. Okay. 1 over the cosine of 60 degrees. Cosine of 60 degrees is a half. 1 divided by a half, divide by a half, same as multiplied by 2. Get my answer. Okay, we're not doing decimals here. If you type these straight into your calculator and are giving me goofy decimal answers, not even pondering the idea, giving you credit. Cosecant, 1 over sine. So, sine of 150. Cosine sine. Sine of 150 is a half. 1 over 1/2. Just did that here. 2. Tangent. You're like, wait, tangent? We just got cosine and sine on there. Tangent is sine over cosine. So what's that mean? Well, negative 120, negative 90, negative 120. Okay, so 240. So this is the similarity of sine of 240. Cosine of 240. Okay, so 240. Cosine and sine. Sine is negative square root of 3 over 2. Cosine of 240 is negative 1/2. But remember, you can multiply by the reciprocal. Divide by negative 1/2, same as multiply as negative 2 over 1. 2's cancel. Negative times negative is positive. Square root of 3. This is why some of you need to do practice when there's homework on this. You've seen this in a couple of other spots. Sine of negative 330. 90, 180, 270, 300, 330. Sine 1/2. Next. Uh-oh, radians. No! Okay, we're just finding values. It doesn't matter if you turn it into degrees. 3 times 180 is 540 divided by 2. is 270 degrees. Tangent is sine over cosine. 270 degrees. Sine over cosine. Negative 1 over 0. I can't divide by 0. It's undefined. Tangent of negative pi over 3. Negative 180 over 3. Tangent of negative 60. Negative 60. The sine of 300 over the cosine of 300. Cosine sine. Sine of 300. Negative square root of 3 over 2. Divided by cosine. Flip it. Divide by 1/2, same as multiplying by 2. Negative square root of 3. Rolling. 3 times 180, 540 divided by 2. Cosine of negative 270. Negative 90, negative 180, negative 270. Cosine. Nada. Cotangent, oh dear, of pi over 2. Okay. Cotangent is the inverse of tangent. So if tangent is sine over cosine, this is going to be cosine over sine. And 180 divided by 2 is 90. Cosine of 90, 0. Sine of 90, 1. And 0. And finally, and just because I'm nice, it's normal, cosine of 315. Okay. Cosine sine square root of 2 over 2. Boom. If you have not practiced those at all, I would suggest doing that tonight a little bit. 21. State what quadrant you are in if tangent, all right, let's do this. If tangent is positive, okay, tangent is positive, has to be one of those two. Tangent or the alt. And cosine is negative. Cosine's not negative here, so that's the one. Not bad. Find the value of x where this is true. Sine of x equals 1/2. Is there more than one solution? Sine is 1/2. Here, 30 degrees. Here, 150 degrees. That looks like it's it though, but 30 degrees, 150 degrees. More than one? Yep. Unit circle, giving me such good things. And then finally, I'll give you the easy part. Using radians, find the amplitude. Is there a number in front? Awesome. And period. Period is not just saying b equals 4. The period occurs when you take 2 pi and divide it by b and simplify it. That's your period. If it doesn't simplify, then you just leave it. But if it does, you better do it. Okay, bottom line. I'm looking at my little timer here. I'm just under 34 minutes. Okay? You have a 46-minute period. Plus passing if you want it, 51 minutes. You're not getting more than that. If you're needing more than that, you're not ready. So here is the exact breakdown. Should look kind of familiar. 4 graphs, like we did on here. 10 exact values, just like we did on here. 2 reference angles. Okay, we did 4, now we're only going to do 2. And 2 degree to radian. Slightly shorter, but plenty of time to get this done. So if you need, grab an extra one of these. Grab an extra unit circle. Practice it. Do your homework. Be ready. Okay? All right. I know you will.